Hello, this is Almir. Another episode of Commuting with the Software Engineer. Today we're continuing from the last episode in which we talked about microservices and 25 things needed to achieve the enterprise level of microservices. In the previous episode, we covered 5 items. In the next slide, I'm going to show you those 5 items. In today's episode, we're covering the next 5 items, items 6 through 10. I'm going to talk about those items that are needed to achieve enterprise level microservices. So basically, items 6 through 10 out of 25 items that will be covered overall in the future episodes. Okay, I found a good spot here on the side of the road. Found a parking lot. Let's change my glasses because it's too bright. I want to put the sunglasses on. So, items number 6 through 10. Let's cover number 6. In order to achieve enterprise level microservices, you need logging, correlation ID, and log levels set up. So as you're developing your microservices or the common libraries for your microservices, you have to figure out what type of logging levels you will need. Obviously, in production, the logging would be smaller, and you cannot log specific information for performance reasons and also for information security reasons. So you typically would have a debug mode, and you would have, for example, a trace mode and an error mode. Maybe the trace mode is not enabled, debug mode is not enabled in production, but the trace mode and the error mode or error log level is enabled in production. Another important thing is the common library changes in order to do the logging. There's no reason for every microservice to reinvent how logging should be done. This should be all coded in a common library for a specific language or languages that you use. And then that common library could be used throughout the code, because the common library encapsulates and defines what the format of a log message is. One important item in the log message itself is the correlation ID. As you make calls from one microservice to another microservice, it is important to propagate the same correlation ID from call to call. So when you're troubleshooting a problem later, you can find an error message, for example, find the correlation ID for that error message, and then trace it back and find the full flow and all the steps that took place in order to get to the point of that error. So to reiterate, item number 6, logging, correlation ID within the logging message, and you have to define clearly what your logging levels are and how you would use those logging levels in pre-production and production environments. Item number 7. Number 7 is the log aggregator tool. So in the previous item, I talked about how you need to have a library that's going to log into some location, but at some point the logs need to end up in some log aggregator tool, so you as the consumer of those logs can easily search for logs and get meaningful results. You don't want to be traversing through a bunch of text files looking for logs, so that's where the log aggregator tool fits in. The tool that I typically recommend, the one that I have experience with, is Splunk. Splunk is one example of log aggregator tool. I'm sure there's many other open source ones that you can use, but for the sake of argument, let's assume you're using Splunk as the log aggregator tool. Now, let's say somebody tells you you're getting errors in production. All you need to do is log into Splunk, specify a specific source type that you're going to search on, and you can say I'm searching for errors on a specific source type, and it will give you all the logs related to that source type. At the same time, depending on what type of attributes you put in the log message itself, and if you put it in the proper format that Splunk can understand, then you can easily search on those attributes. You can say, give me all the errors for microservice A, or give me all the positive logs for microservice A or microservice B. So these are the type of things that log aggregator tool can help you with. Number 8. Number 8 is exception handling in your code. I just want to clarify that exception handling is different from error handling. Exception handling is you basically going through the code, and let's assume you have a microservice that has, even though it's a small service, the amount of code that you have is small, you still would have multiple layers within your microservice. You would have your controller or your resource layer, the entry point for your API, then you may have your business layer, down below you may have repository layer that interacts with the database of your choice of database. So you have these multiple layers of classes and methods where you put your methods and classes and do your implementation. Now the error can happen in any of these layers. If it happens at the repository layer, you have to know whether you need to do try and catch statement. What happens if you do it at the business layer? Do you need to do try and catch? What about at the top level, the entry point into the API, which is the controller level or resource level? That's where you need to define the approach for try and catch statements. For example, there's no reason to do a try and catch at the low level if there's nothing to be enriched. If there's no data that you need to enrich, or the log message that you need, you can just allow that message to go to the higher level, and you may catch it at the higher level where you have some other information that you may log, or you also may decide not to catch it and leave at the middle level. Maybe you catch it at the very top level. There's no right or wrong. Everybody does it differently. As long as you agree within your company what your approach is, and as long as there's a clear understanding, and as long as there's a clear understanding among all developers. So now we get into the error handling for number 9. In the number 8, I talked about exception handling, and I mentioned that exception handling is different than error handling. So in this item number 9, error handling is different. For example, error handling is what you define is a superset of exception handling. For example, you should always strive to define what your errors are through some if and else conditions in your code, but if you cannot, you have to rely on the exceptions. You may catch an exception, convert it into some error, and then define some error code for it. That's why I'm saying error handling is a superset of exception handling, and also other errors that you may discover in your code, but through some if, and else statements throughout your methods. So you have to clearly define what errors get back to the client or the caller of your API. So in the response, you have to clearly define your HTTP codes, what each code means. For example, if you're using standard codes, HTTP 400 means the bad request, HTTP 404 means not found, things like that. You may not need error message to supplement it by you, but at the same time, if you're getting specific business logic errors and you don't want to bundle it into an existing HTTP codes, you may use custom HTTP codes. For example, behind the scenes you may have problems in interacting with your database or some third-party provider. People are calling your API. You may translate that issue that you're having behind the scenes to custom HTTP code, maybe 530s, 540s range. Define a specific HTTP code, custom HTTP code for that, and enrich it with the error message. It is also important that when you are the response of your API calls is clearly defined in the case of errors. So you have to have a standard error message for API call responses so that your clients can easily understand what that message is and they can code for it. Number 10 is timeouts. typically timeouts get forgotten in the software development. People write their code, and whatever the defaults are for the given libraries that they're using, and then when issues start happening in production or pre-production environments, you realize that you need to take care of your timeouts. So you have to clearly define, you have to understand what your microservice is doing and whom it is interacting with. If your microservice is talking to some third party and the performance of that third party API is not as good as you want it to be, you have to now define what timeout you have to give to the callers of your API. Yes, your API is calling somebody behind the scenes, and you may say, yeah, 15-second timeout is not good enough because I'm dependent on third party. You may increase that timeout to 25 seconds, for example. So when somebody calls your API, they get a chance to get a response back. You don't want too many timeouts happening at the same time, but you don't want too many timeouts happening, but at the same time you don't want to hide or suppress the problems that you're having. In an ideal situation, it would be good to have a dynamic timeout. You start with a soft timeout, and let's say your clients you start having a soft timeout, and then as people are using your API and you're tracking what the average timeout is, and you may keep increasing it to a point where eventually you have a hard timeout, and then really the clients are getting a timeout message on their side. But behind the scenes, while you're in that soft timeout mode, clients will not know. We will be increasing the timeout so we can give the client the response, but eventually we have to give up. That means there is a real problem happening if you're running in a soft timeout mode for a long time. Then you really have to hit the hard timeout and give the timeout message back to the caller. So the overall message for number 10 with the timeouts is you have to think about it explicitly. Do not rely on the defaults in your libraries. And also you need to understand what your microservice is doing, what third-party APIs your microservice is dependent on in order to determine the proper timeout to start with. And if you're using concept of dynamic timeouts, you have to know what that soft limit is and what the hard limit is. That's pretty much items 6 through 10 for the topic of microservices and how to get microservices to be at the enterprise level. So in the previous episode we covered items 1 through 5. In this episode we covered items 6 through 10, and there's 25 items overall that I need to cover with you. In the future episodes I will cover the remaining items. Thank you for watching. Please click that thumbs up button, and don't forget to subscribe. I'll see you in the next episode. Keep geeking out.